Welcome back, Physical Science 20. We'll look at the last two stoichiometry examples. So these are very similar to the previous one we just did. Again, we're going to be starting off with grams. We have to convert to moles, then find the limiting reagent. So here, iron reacts with chlorine gas to form iron 3 chloride. Determine the limiting reagent when we have 5 grams of iron. So we'll write that underneath. Combined with 9 grams of chlorine. And of course, once we figure out that, we'll use the limiting reagent to figure out what mass of iron 3 chloride is produced. So again, we're going to have to figure out how many moles, and yes, we'll use whatever one of those is the limiting to figure out how many moles of this. So of course, that involves figuring out the molar mass of all 3 of those. So over here, part A, figure out the molar mass of iron, the molar mass of chlorine, and the molar mass of iron 3 chloride. So of course here we have 1 iron. Iron on the periodic table is 55.93, so 55.93 grams per mole. 2 chlorines over here. Each chlorine is 35.45. So that gives us 70.9 grams per mole. And then lastly here, iron and chlorine. 55.93 is iron. Chlorine again, 35.45. So 162.28 grams per mole. All right, so convert each of these to moles now. So 5 grams of iron. 5 grams of iron. And iron here, 55.93 grams of iron is 1 mole of iron. So that works out to be 0.0893 moles of iron. So we'll just put that up there. We put the number of moles on top. 9 grams of chlorine. So 9 grams of chlorine, and according to the molar mass, there's 70.90 grams of chlorine in 1 mole of chlorine. So that's going to give us 0.1269 moles of chlorine. 0.1269. It's a 2 to 3 ratio here, so we'll have to figure out which one gets used up and which one doesn't. So we'll start off with this 0.0893 moles of iron. And I'm going to be comparing moles of iron with moles of chlorine. And of course, according to the balanced equation, 2 moles requires 3 moles. 2 moles requires 3 moles. So moles and moles cancel. That's going to give me this. Going vice versa, 0.1269 moles of chlorine. And this time, if I try to use up all the moles of chlorine to see how many moles of iron are required, moles of chlorine to moles of iron, 3 to 2. 3 to 2. So that's going to give me 0.0846 moles of iron required. So now I just have to see which one works. If I try to use up all the iron, 0.0893, I need 0.1339. I don't have it. So iron is not limiting. So that'll tell you right off the bat that it has to be this. But let's just take a look. If I try to use up the 0.1269 moles of chlorine, I need 0.0846. And I have 0.0893. I have way more than I need. I only need 0.0846, but I got 0.0893. So that tells us that this works. And therefore, Cl2 is the limiting reagent. Okay. So now that I know what the limiting reagent is, I know it's going to be chlorine. So that's what I'm going to use to figure out how many moles of product I make, and then I can convert that into grams. So going with that, my 0.1269 moles of chlorine, and then going from moles of chlorine to moles of what I'm making, iron 3 chloride. According to this, it's a 3:2 ratio. 3:2 ratio. So if I was to stop here, I'd have moles of iron 3 chloride, but I want to go one more step, go to grams. And of course that involves using the molar mass. For every 1 mole of iron chloride, here's the molar mass up here, 162.28 grams of iron chloride. So multiply all the numerators, divide by all the denominators. I think you get something like this. And of course, if I look here, 3 sig figs, 3 sig figs. So I'll go with 3 sig figs, 13.7 grams, FeCl3 produced. All right, we have one more example to do. Why don't you run through that, and then we'll go through it in a second or two. So just pause the video and try it out. Okay, Physical Science 20, we'll finish off this last one. Ammonia reacts with oxygen to make nitrogen monoxide and water. So I have 0.34 grams of ammonia and 1 gram of oxygen. And eventually we'll figure out what's the mass of nitrogen monoxide. So it doesn't ask anything about water, but it could have asked for water too, but hey, we don't have to worry about it. So yes, we're going to figure out how many moles, and then yes, we're going to have to eventually figure out how many moles of that we have being formed. So let's figure out the molar mass of all of these, because we have to go from grams to moles. So the molar mass of ammonia, the molar mass of oxygen, and the molar mass of NO. So 1 nitrogen, 3 hydrogens, so 14.01. Oops. So 17.04 grams per mole is the molar mass of ammonia. Oxygen, I have 2 of them, 2 moles. So that's 13 grams per mole. Nitrogen monoxide, I have 1 of each. So 14, 16, 3.01 grams per mole. Okay, so now the next step, now that I know that, convert each of those into moles. So 0.34 grams of ammonia, and here I have for every 17.04 G's of ammonia, that's 1 mole of ammonia. So that converts to 0.0199 moles of ammonia. Same thing over here, a gram of oxygen. According to that, 32 G's is 1 mole. So that's going to work out to be 0.0312 moles of O2. All right, figure what's limiting. It's a 4:5 ratio. So if I look over here, 0.0199 moles of ammonia. And if I'm going from moles of ammonia to moles of oxygen, moles of ammonia to moles of oxygen, 4:5, 4:5. That's going to give me 0.0248 moles of O2 required. Oops. Vice versa. If I try, I guess I could have wrote this up here. Let's see here. So I have 0.0199 moles, and down here I had 0.0312. Okay, so I tried to use that up. Yeah, so I tried to use that. Vice versa now. What if I try to use up all the oxygen? 0.0312 moles of oxygen. This time I'm comparing moles of oxygen to moles of ammonia. Moles of oxygen to moles of ammonia, 5:4. 5:4, and I get 0.0249 moles of ammonia required. So let's see which one works. If I try to use up all the 0.0199 moles of ammonia, I need 0.0248. Do I have it? Yes, and I have way more. So that's the one that's going to work. Let's look at why the other one doesn't work. 0.0312. If I try to use up all the 0.0312, I need 0.0249 of ammonia. Do I have it? No, I only have 0.0199. So that doesn't work. So therefore, limiting reagent ammonia. Because it's all going to get used up. Okay, so I'm going to be using ammonia now. It's kind of awkward to show this, but I'm going to be using this to figure out how many moles of this, nitrogen monoxide, and then figure out how many G's. So part B, I'm going to be using up all of the ammonia. And according to this, 4 moles makes 4 moles. 4 moles makes 4 moles of nitrogen monoxide. So if I was to stop the question there, I'd have moles of nitrogen monoxide. Of course, I'm going to go to one more step, figure out how many grams I have. So for every 1 mole of nitrogen monoxide, according to the molar mass, 1 mole is 30 Gs. 1 mole is 30.01 Gs. So that's going to give me 0.5971 Gs. If I look at the 2 sigs, 3 sigs, so I'll just go with 2 sig figs here. Let's keep that, keep that. That's a 7, so that gets bumped up. So there we have it, folks. Stoichiometry, dealing with mass to mass, that's the last example. So you should be able to do the assignment with this section now. All right, we'll see you again.